So the first example I'm going to show here is how we use the jammer to modify a TLP to cause an LCRC error. So the background behind this is we're going to send a configuration read, as we discussed a moment ago. We're going to modify this TLP, which is going to create a bad LCRC on the other side of the jammer. That's going to cause a NAC to happen. The NAC will go through, and we'll see that in the trace. The configuration read is going to be replayed again, and then it's going to go through correctly the second time. It should be acknowledged, the completion with data comes back, and then that gets acknowledged and the transaction is complete. We set that up in the recording options like this. So we have a configuration read, and that we choose modify as the jammer action, and then the register field is changed from a 0 to a 1, and then the trace should look like this. So the summary of what happens is the jammer modifies the register field in the config read from TLP, the config read TLP from 0 to 1, results in a bad LCRC, device sends the NAC, causes the config read to be replayed, the device then sends the ACK and the completion with data. Let's now take a look how that looks like on the live system. So what I'm going to do here is I'm going to set up the jammer, the Summit M5x, to record and to jam a packet. So the first thing I need to do is set up the generation options in the GUI. So I open setup generation options. I'm going to select the link width as appropriate. The device under test that I have here is a by 4 device. So I'm going to set the link width to by 4, and it's a device that's capable of 16 gigatransfers per second. So I'm going to set that to the maximum here. Other link settings, I'm going to make sure the link goes through the equalization phase 2 and 3, and then the 5 parameters are the preset values that we're going to use for this device. So in this case, we're going to use preset 7 for 8 gig and for 16 gig. So now that the generations options have been set, once we OK that, we're going to establish the link and bring the link to the L0 state by pressing the connect button. So now we can see that the link came to the L0 state, the link width is by 4, and the speed is 2.5 gigatransfers per second. I can press the go to 16 gigatransfers per second button, which will take it firstly to 8 gigatransfers per second, and then on the second press, we'll go to 16 gigatransfers per second. So I can see the link is now in the L0 state, a by 4 link width at 16 gigatransfers per second. I can use the LTSSM test arc GUI to read the LTSSM log to ensure that the link is stable at 16 gigatransfers per second with no recoveries happening. So I can see that is the case here. The next thing I need to do is I need to create a condition that I'm going to use as a jam. So I do that under the recording options. So I can either do setup and then recording options, or I can push the button on the toolbar here. By default, the recording options are set here to the advanced mode for an event trigger. We're going to use mostly default settings here, auto speed and auto link width. But the key part here is to go to the recording rules. And we're going to set up a jam scenario. In this case, we're going to set up a jam scenario based on a configuration read. So the details are shown here. The configuration read will be the trigger condition. It'll also be the condition for the jam. So we're going to choose under the actions menu to trigger the analyzer, and then under the jammer actions, in this case we're going to do modify. We're going to do it one time, and then we're going to change the field that we modify to be the register field. So instead of reading from register 0, I'm going to read from register 1. And we OK that, we OK that, we OK that. The next thing we need to do is load a script for the exerciser. The exerciser will be creating the traffic, and in this case the traffic will be a configuration read to the device. This would read the device and vendor ID from the device. Now what I can do firstly is to record only the traffic that the exerciser is going to generate. Then the second time I run this, I will record with the jam scenario. So I'm going to start the analyzer only and then start the exerciser. You can see that the analyzer triggered, the memory buffer filled, and then we have the trace file. Now, just to make it easier to look, I'm going to hide all flow control updates and skip ordered sets and EDS frames. So we can see that we have a configuration read, an acknowledge, completion, and an acknowledge. So this is a simple case. This is the traffic that we created from the exerciser through the jammer to the endpoint device. Now I'm going to run the same scenario again, but instead of doing analyzer, I'm going to start the analyzer and the jammer by pushing this button here. It says start jamming and recording. So when I do that, we can see it's waiting for the trigger. I go to the window here, the trainer script, do the same thing again, run the exerciser. You can see the buffer fills, the analyzer triggers, and this time, again, I'll hide the update flow controls and skip ordered sets. We can see that we had the configuration read from the exerciser. We saw a knack. This is because the CRC was broken on the configuration read. So the configuration read was replayed again, and then we see the acknowledge from the endpoint and then the completion with the endpoint. Now, if I want to see what actually happened within the jammer, this was the original packet. I'm just going to turn on the wrap here. The original packet and then the modified packet. Now what this is going to do is highlight the field that we changed in the original packet. So this jam packet here is what applies to the packet next to it. So this configuration read, we basically changed this register field here to be a 1 instead of a 0. Now what we didn't do is we didn't observe the rules. So by modifying 1 bit in the packet, this caused an LCRC error to happen, which in turn caused the knack to be sent from the endpoint, which in turn forced the replay of the configuration read.